Good afternoon, everyone. Welcome to the talk. About 15 years ago, when I first left China to come to the United States to attend graduate school at Virginia Tech, I'm a little bit excited, but also with a lot of uncertainty. I worried if I can adjust to culture here. I worried if my English could be understood by other people because of my accent. After I come to the state and meet all these awesome people, I found out my experience is as smooth as I could imagine. Likewise, no matter if this is your first time to run SQL Server or migrating your existing SQL Server workload to the Google Cloud, I hope your experience will be just as smooth as mine. Our top enterprise customer often surprised to learn that Google underlying infrastructure is the best place to run your existing enterprise workload. Windows and the SQL Server is no exception. Today, I'll be talking about run Microsoft SQL Server on Google Computer Engine. Just a little bit about myself. My name is Feng Min. I'm the tech lead for the Windows team at the Google Computer Engine. My team works on a lot of different areas, from the guest device driver to the host hypervisor, from the BIOS, firmware, to the Win32 userland service. We want to make sure our customer to able to run the SQL Server in the Windows virtual machine hosted by the Google Computer Engine. We want it to be performant, secure, and reliable. Here's the rough agenda for today. In the beginning, we'll go over the history about the Windows and the SQL Server on Google Computer Engine. We'll talk about how to create and configure SQL Server instance. We will go over some performance improvement, which is critical for the SQL Server workload. After that, my colleague Annabelle will go on stage to talk about how to deploy SQL Server always-on availability group using the PowerShell with an interesting live field demo. After demo, we will talk about the storage and the backup, and we will share some tips and the best practice for the disaster recovery, and also for the performance tuning. So, our journey with Windows and the SQL Server started a little bit over 2 years ago when we launched Windows Server 2008 R2 support on Google Computer Engine in the end of 2014. In summer 2015, we announced the general availability for the Windows Server on GCE, including the support for the Windows Server 2008 R2 and the 2012 R2. Moving into 2016, we added support for the SQL Server Standard and the SQL Server Web Edition. Immediately after Microsoft announced the availability for the Windows Server 2016, within a week, Google Cloud Platform was able to launch the support for the 2016 on the Google Computer Engine. It demonstrated Google's commitment for the enterprise customer. Early this year, we added support for the SQL Server Enterprise, including always-on availability group support. So, why do I think it's a good idea to bring your SQL Server workload to GCE? First, GCE is a powerful platform which has a lot of advanced features which will really power up your SQL Server. We support VSS integrated PD Snapshot. It brings the data consistency of your snapshot to the application consistent. Together with the built-in SQL Server backup support, it makes it really powerful tool to make sure take your backup and while the instance is running without interrupted. We support SQL Server Enterprise Edition with the always-on clustering support, allowing you to configure multiple replica for automatic failover in case of failure. Google-grade infrastructure is the reason why Google is leading price to performance. On the networking side, our Windows VM to VM throughput can reach up to 16 gigabit per second. On the storage side, our PDSSD was able to deliver up to 40K IOPS, all without extra cost. Second, Google Cloud Platform and Google Computer Engine is also a flexible platform. The per minute billing gives you fast granularity to control your cost. With sustained usage discount, you don't have to make upfront commitment. No lock-in. If you keep using, the discount will kick in automatically. The custom machine type will give the administrator the full control, specify the machine with the CPU and the memory configuration which match with the enterprise needs. We also have a very flexible license model. Let's take a look at what the license model we have. So we support the 2 different license models: bring your own license or pay as you go. For the bring your own license, customer can choose to bring over their existing enterprise agreement with the software assurance for the SQL Server and also other Microsoft Server product like Exchange Server, SharePoint Server to the Google Cloud. The second option is pay as you go, only for what you use. Google provides a pre-configured image with SQL Server pre-installed. Together with the permanent billing and the sustained usage discount, this makes it a very flexible option to control your license cost. We talked about the price already, right? So we already go over the permanent billing and the sustained usage discount. I won't repeat here. For SQL Server VM price, it consists of 3 parts. First part is base VM price, and also need to pay the Windows license cost and also the SQL Server license cost. I would like to point out here for the free trial. Our free trial is available for all the SQL Server image, including the most premium SQL Server Enterprise Edition. So, how to create a SQL Server VM? The way to create a SQL Server VM is very similar to how you create a regular Windows virtual machine. To find out how many different SQL Server images we support on Google Cloud, here's the gcloud command you can run. The trick here, you need to specify that your image project as a Windows SQL Cloud. Alternatively, you can also go to the Application tab on the Cloud Console. You can find the list of all the available SQL Server image on the different Windows version we support. If you find a particular configuration you need but not in the list, please reach out to us. Performance. Everyone loves performance, right? Over the last year, we shipped a dozen features across different product areas to improve the SQL Server experience on GCE. Here's a few like a performance improvement highlight I'd like to show you. Having a clock in the computer system is important. It will be even better if the clock can be accurate and the cost to access the clock is low. It turns out it's actually rather difficult to implement accurate and efficient timer in virtualized environment. Most implementation come with some performance cost. The server application, like SQL Server, do a lot of sampling to measure the operation latency. So that's why having efficient timer implementation is extremely important for server workload on a cloud environment. Reference TSC is a Hyper-V environment, which allowed the virtual machine to access clock with native performance without any performance loss. It can also help bring to keep the clock accurate even when you migrate the machine among different hosts. To support this feature in cloud environment, it's much more difficult to support this on-premise environment. We are very proud to be the first cloud provider to be able to support this feature. In our internal testing, when we run the TPCC benchmark, of course, it do a lot of timer access, right? We see the CPU usage can drop up to 20 to 30%. All these precious CPU cycle could be used to something more useful rather than waste on the access the timer. We also made our storage stack and the network stack more efficient. I already talked about the network throughput, the PD SSD. But also SCSI multi-queue is another feature which is super useful for our local SSD offering on the Windows. It makes our virtual storage adapter more efficient with lower latency and higher throughput. Since we released the SQL Server Standard Edition last year, a top question from the customer is, when Google will start to support SQL Server Enterprise with always-on clustering support. So here we are. Mission-critical SQL Server workload require high availability and disaster recovery. To achieve this, Google Cloud Platform support Windows Server failover cluster and the always-on availability group. Always-on availability group is SQL Server flagship HADR solution, allowing you to configure multiple replica for automatic failover in case of failure. This replica can be configured as readable, allowing you to offload the read workload and the backup. So look at this reference architecture. You need the two custom subnetwork here. Each custom subnetwork will host one SQL Server instance. The domain controller on the top can be the same or different subnetwork, doesn't matter. You will also need the Active Directory, as with most typical Windows workload. And we will also promote this domain controller to the DNS server. For both SQL instance, we need to join this Active Directory and also update the DNS setting to use this DNS server. So that's important. The default GCE DNS will not work here. In order to specify the cluster IP and the listener IP, right, when you're building out your cluster, we need to switch from the DHCP to the static IP, and also configure the IP address using the GCP advanced routing so that the packet can be forwarded to the correct node. So, in this reference architecture on the last slide, I talk about a lot like how you do that. So now I want to talk a little bit of why you want to do that. What's the reason behind that? First, I like to point out that the slide I just showed you is like a regional HA configuration. However, you can configure two subnets in the same zone, or even configure two different subnets across different regions to make it cross-region HA configuration. Of course, if it is cross-region, you may want to configure your SQL replication using asynchronous replication instead of synchronous replication to mitigate the latency issue. Second, the whole solution was building on top like a multi-site failover cluster. Because it's multi-site, that's the reason we need two or more customer subnetwork here. It also means the SQL client need to support something called the multi-subnet failover option in the connection string. So when you're building an application, you specify the connection string to connect to SQL Server database, right? That's the option you need to specify. It means on your client side, usually you need to run like an ADO, like 4.5 or newer. Because this, it brings us like a fast failover time. In our internal testing, we usually can be finish this whole failover in the 10 to 15 seconds. Let's talk about a little bit about IP address. Cloud network usually is very different from the traditional on-premise network we've seen. On a high level, GCE networking is a big layer 3 switch. The usual feature like a DHCP, broadcast, up, does not really work the same way as you expected in the traditional network. The GCE network doesn't know about the IP address, the virtual IP you configure, like a listen IP, cluster IP you configure in the cluster. So it will not automatically assign this IP address to your VM. That's why we need to switch from DHCP to the static IP and also use the routing to configure this IP address so the packet can be forwarded to the correct SQL instance. As we configure SQL Server the GCE advanced routing for the cluster IP and the listener IP, by the GCE routing definition, the IP address has to be outside of the valid GCP subnetwork address range, because this is user-defined routing. If it's inside the range, the routing is already predefined. But however, from guest perspective, right, this IP has to be in the same subnet as the primary internal IP from VM perspective. I know it's a little bit of confusion. Let's see an example. So here's a typical network configuration we use. We have two subnetworks here, 10.1.1.0 and 10.2.1.0. They are both /24 network. Right? That's how you create your GCE custom subnetwork. On the VM side, you can see that for both VM, they have a subnet mask as 255.255.0.0. So they are both /16 subnetwork, which is also a superset of the GCE subnetwork view. When we pick up a listener IP, we just need to pick up the IP address, which is outside of the GCE subnetwork range, but inside the VM subnetwork mask view. Take IP1, listener IP1 example, right? 10.1.2.4, which is outside of subnet 1. 10.1.1.0/24 is outside. But it is inside of the subnet mask as defined by 255.255.0.0, which is the same network as the internal IP. The same is also true for the internal listener IP2. So I want you understand this picture. So that's how you pick up correct listener IP and cluster IP to configure your always-on cluster. For a customer to bring your own license to the Google Cloud, there's an extra work they need to do to follow. To get all these network changes I just talking about, they need to mark their customer image as a multi-IP capable. To do that, you first create a disk using a pre-configured Google image. Then you create a new custom image using the command here, specify the new flag, guest OS feature flag called the multi-IP subnet. Once this is enabled, you get all the network feature I'm talking about in the previous slide. For the pre-configured image released by Google using the PSQL license, all of this has been automatically taken care of. You don't need to worry about this. So I just talked a lot about the availability group on the GCE. The manual deploy need a lot of steps. It's very complicated, to be honest. With that, let me hand over to my colleague Annibal. He will talk how to deploy the always-on availability group using PowerShell efficiently, and he will also show us demo to using availability group to handle the failure.
Thank you, Feng. So my name is Aníbal Santiago. I'm a database engineer with Google. I've been working with SQL Server for at least a little bit more than 20 years. I actually started when it was called Site-Based SQL Server. And I'm also a Microsoft Certified Solutions Associate in SQL Server 2012 and 2014. So with the Google Cloud SDK, you have access to the PowerShell commandlets that lets you manage your Google Cloud environment. We created a SQL Server high availability cluster using PowerShell, and that's the one that I'll be demonstrating to you. The code that we use to create this cluster is in GitHub, so you will be able just to go to GitHub, see the code, download it, and even modify it to match your needs. After that, I will do a second demo of a Cloud Launcher template that will do the same thing. It will create a high availability cluster for you. This one is useful when you want to do like a quick tour of SQL Server HA, because you pretty much just click and the whole environment will be created for you. So let's go to the demo. So first, I just wanted to just quickly show, this is the location, and you will see the link later on, where the code that I'll be showing you resides. But even before I go to the actual code, let me just show you a little bit how if you are using the Google Cloud console, how things will look like. This is after running it. In this case, we have two nodes, cluster SQL1, cluster SQL2, and a domain called DC Windows. One thing that I just wanted to kind of emphasize is like, thing to be aware. Like, when you set up your firewall, notice how I created 3 firewalls. And those firewalls, I did have to create them myself. There's one that I call allow internal ports that just pretty much allow all traffic between the 3 nodes. I created one called allow RDP. Specifically, we want to open port 3389. Now, this one, I really open it to the world. In your case, you don't need to do that. But for simplicity, I'm just saying anyone from the world can really try to do an RDP, but just be aware of that. The other thing that we're going to need when we do our PowerShell deployment is open port 5986, because we will be using WinRM to connect to those instances. So we will also need to open that port. So besides those 3 firewalls, let me just talk a little bit about 4 routes. Later on, I know that Feng talked about this concept, but we will need to create routes in GCP for the virtual IPs for the Windows failover cluster and the SQL Server listener, availability group listener. So these are the 4 routes that we also create. In general, I just wanted to mention those 2 things, because those are the things that you will have to set up once you get everything running, if you're doing it manually, because actually the PowerShell script will do that all for you. So let's take a quick look at the code. Actually, I'm going to minimize this just now. So just a little bit of summary about the code. We split the logic into 3 script files. At the end, you only need to run one, but we figured that it's easier to understand just by splitting the logic into 3 files. The first file that we call parameters config, you just enter anything that is related to your environment. The name of your node, the IPs, the name of your network. There's a space in there which specify the name of your domain and all of that kind of information. So this is the place where you will customize for this installation. The other script is the main one, and this is the one that you will always run. This is the one that we call create SQL Instance availability groups. On the top of the file, we put a lot of information just to kind of, I just want to maximize this to make it easier to read. So just to show you a little bit more, like you have an idea what it does. Now, I'm not going to read each and every line of the code, but still I'm just going to give you like the highlights of what it does. You will notice how everywhere we are using those commandlets that, unless you are familiar with the Google Cloud SDK for PowerShell, those are some of the commandlets that you get once you install the Google Cloud SDK. So we go to the process of first deleting the instances if they exist. We will then create boot disks for our 2 instances. Back again, there's different examples on how to use the Google Cloud SDK. We go out, we then will create the instances. Now, every time you create a Windows instance, or actually any instance in Google Cloud, they are not available immediately. You usually have to wait a few minutes for them to be ready. So this part of the code just does that. It will wait until the instances are ready. Once the instances are ready, we need to generate a password in order to be able to log on to those servers. So in this section, we just generate the password. Now, this is the section where we create those 4 routes that I talked to you about and that we mentioned earlier. So it creates the route for the virtual IPs for the cluster and the listener. And then we start to pretty much connect. We put a message here just to make sure that, very important, that you better have port 5986 open. And usually if you don't, this is the point where it will fail. So one of the first steps that we do when we log on to the server, we change the network IP to be static. So this is what we're doing here, just changing the network IP to be static. One thing that happens at the moment that you change the network IP to be static, you lose your connection. So just to make it cleaner, we remove those session variables, connection variables, and we will recreate them. And back again, we try to connect to the server. From this point on, it's just doing all the other stuff that you need to do when setting up SQL Server. We create folders, directories, where we're going to start the database. We open the firewall. This is the Windows firewall, port 5022 for availability group, port 1433 for SQL Server. We enable the clustering feature of Windows, since we are going to need it later on. And finally, we add the computers to the domain. Once the computers are added to the domain, the server will restart. And that happens automatically. And pretty much once they are added to the domain, we are ready to start creating the cluster. So once again, this section, we're just waiting for the computers to restart. But once they do, we just print a message that says, we are ready to create a Windows failover cluster. At that moment, we are going to try to create the Windows failover cluster. This is the point where we decided to put the logic still in a third file, which is the third file that I'm going to show in a moment. It's called the create availability group.ps1. Why did we put that one still in a different file? If you're bringing your own license, you will not have SQL Server pre-installed. You will have to install it yourself. So what the code will do at this moment, it will tell you. It will check to see if SQL Server is installed. If it's not, it will tell you, please install SQL Server. And then it will tell you, run this other script after you are done. But if you are just if you are just using the pay-as-you-go, the whole thing will continue automatically. Now, a little bit thing about this other one, the script that creates the SQL Server availability group. This script has no command related to Google Cloud. So this is just a script that you can use to install and set up a SQL Server availability group. So let's say that on your own environment, talking about on-premise, if you just want to set up a SQL Server availability group, you can just take this section of the code and just really use it. So this one has nothing to do, per se, with Google Cloud. So let's go to a little bit demo, and we are going to test like a planned failover and an unplanned failover. Before doing that, I just want to show you what is the code that I'm using to test that failover. So I just wrote like a very simple PowerShell script that it has a function that runs a query. So it will run any query that I pass. Below, the query that I'm just passing to that function is, I'm adding a record into a table. Immediately after, I'm just counting how many records the table has. And when I return, I'm returning how many records the table has and also the name of the server. The only reason why I return the name of the server is just because I want to show you how the server name changes when we do the failover. And I will also print, and you will see it in a different color, how many seconds it took to do the failover. So in this blue window is where you find that little piece of code. So I'm just going to start it. On the left, it tells you kind of how many records are in that table. Right now, we are connected to cluster SQL 2. So there are multiple ways to do a failover. I'm going to use PowerShell. But know that you can do that from SQL Server Management Studio as well. But this is the command to change it to cluster SQL 1. And you will notice here. So let's run it. So let's see how long it takes to do the switch. What you will expect in the blue window is the name cluster SQL 1 after doing the failover. So we get the error. And it took 10 seconds. And we are back now running in cluster SQL 1. So this is like testing how you will do like a planned failover. So now, let's plan to do like an unplanned failover. What I'm going to do for this one, I'm just going to restart cluster SQL 1, since that's a currently active node. So I already have the command here. So I'm just do a full restart of the server. What we'll expect after we do this restart is that cluster SQL 2 will become the one active. And if I'm able to enter the enter, OK. So let me minimize that while. And in this case, you see it took 5 seconds to do the switch. In this case, you will not see the error. The query is sleeping every 1 second. So it looks like the whole thing happens within that time. And at the end, that's really the only thing that pretty much we test when doing with failover. It is like, does it work or does it doesn't work? So let me go now and talk a little bit more about the other demo that I said we would do, which is the Cloud Launcher template. So from the Google console, you can launch this Cloud Launcher. And in here, I mean, there is a long list. So I do suggest you just start SQL, and you will find quickly the one for SQL Server, which is this first one. It gives you some information, so we'll continue. Now, for the deployment name, you can choose the name that it gives you, or you can just type a new name. You have the option to choose the zone. You will need to specify a domain. That is the only, if you just want to do it quickly, that is the only thing that you have, you always have to enter. So in this case, I'm going to say, create a domain called dveng.com. Below, you will see how you configure your domain controller. In this case, I'm just choosing one CPU. The Windows version I'm going to use is going to be Windows Server 2016. Now, the template only supports for now Windows Server 2016. We are planning to add more versions. Then you can choose type of disk, how big the disk. Then it's the configuration for SQL Server. You can choose between 2 or 3 SQL Server nodes. Same thing, how many CPUs. Also, we only support SQL Server 2016 on Windows Server 2016, but we are planning to add the others. The option is you just want to open the firewall to the public and click deploy. Once you click deploy, it will take 30 minutes. But pretty much after 30 minutes, you will have a working SQL Server high availability cluster for you to test. And with that, I will just switch back again to Feng to continue with the presentation.
Thank you, Anibal, for the demo. Now let's talk about the backup and the disaster recovery. There's a lot of different options we can choose here. First one, you can continue to use built-in the SQL Server backup capability. You can use the SQL Server Managed Studio, T-SQL, or PowerShell commandlet to do the backup. Second, you can leverage always-on availability group to have a multiple replica, ideally across different zone or even different region. If one zone fails, the service can just automatically fail over to different zone. Log shipping is another option. The last option I want to point out here is you can use PD persistent disk snapshot integrated with the Windows Volume Shadow Copy service. It will back up your database, right, with application consistent and make sure your service is keep running without interrupted. If you want to know more about the disaster recovery, I want to point you to the white paper here. It's written by our famous SQL Server expert in the Brand Ozen in this SQL Server community, and Brand is also here. You're welcome to talk with him after the talk. This white paper discussed the disaster recovery for the SQL Server on GCE in great detail. I mentioned multiple times already, PD Snapshot with the VSS integration is something very powerful and useful for running your SQL Server on Google Computer Engine. So why is that? So, what VSS? VSS is technology including the Microsoft Windows, which allow you to take a manual or automatic backup for the volume even when they are in use. Without the VSS integration, the persistent disk snapshot is not aware of any guest state. It's called crash consistent. For a running system, it's just like you put cable from the wall, whatever left on the disk is your snapshot. That's why on the Windows, the often suggestion to do a snapshot is turn off your instance before you take snapshot. This is less than ideal. For a typical operation, the VSS request here will send the request to the VSS service. And the VSS service will send a notification to all the VSS writer registered in the system, including the SQL Server VSS writer, to tell you, hey, I'm going to take a snapshot. Please get yourself ready. So all the VSS writer, we are starting, like a SQL Server VSS writer, we are starting to coordinate its internal state. For example, you need to flush the internal cache to get itself into a self-consistent state. After everybody replied a yes to the VSS service, the VSS, no, everyone is ready, so he will float in the I/O and send the request to the VSS writer, say, please take a snapshot. So the workflow showed us that's why we can take application consistent snapshot, because the storage system is working with the application like SQL Server to do the backup. By integrating the PD Snapshot with the Windows VSS, you combine the benefit of like super fast PD Snapshot with the consistency guarantee from the VSS. You get all of this without affecting your running instance. It's making it ideal tool to do the SQL Server backup. Let me talk about a little bit more for all the internal component involved with the PD VSS stuff. Internally, we have a Google VSS agent running, and we also have a Google VSS provider in every Windows VM instance in the Google Computer Engine. On the back end, when the persistent disk receives a request to take a snapshot, the hypervisor will using extended VDIL protocol to send the signal to the guest VDIL driver. The VDIL driver will wake up the VSS agent. VSS agent now act just like a requester. He will notify the VSS service to say, I want to take a snapshot. Once VSS service get the confirmation from all the writer, including SQL Server, then the VSS service will notify our Google VSS provider, say, please take a snapshot. Our provider here will not take snapshot. Instead, he will just send a notification to the VSS driver, the SCSI driver, and also backend the PD service say, from guest perspective, we are ready. We already coordinated our internal state. We are self-consistent. So you can go ahead with your snapshot. This is already simplified high-level overview for how the workflow working together. But you should get a good idea how everything working together to do a VSS-enabled snapshot. Well, the internal logic is quite complicated to actually implement the PD VSS Enlightened snapshot. To use that, to take a VSS-enabled snapshot, it's actually very easy. We add a new parameter in the existing disk snapshot API called the getFlash. Depends on this parameter is true or false, our PD snapshot workflow will decide whether or not to involve all these guest components to finish the snapshot. By default, this flag, getFlash flag, is false unless you specify it explicitly. As with any other GCP feature, you have 3 different ways to use this feature. You can use the API directly, you can use gcloud command line, and you can also use in Cloud Console. As always, performance tuning is always important part of the topic for the SQL Server. After all, it's still SQL Server, no matter if it's GCE or not GCE. So all your existing knowledge for the performance tuning for the SQL Server, most of them still applicable here. I want to point out some difference on the GCE. First, there's a different storage option on GC, local SSD versus PD SSD. So which storage option should I use? Local SSD is faster, much faster than the PD SSD, but it's not as durable as the PD SSD. In general, for the database workload, we suggest you go with the PD SSD. If you want to go with local SSD, you need to configure using always on availability group, configure multiple replica, right, to just prepare for the failure. However, local SSD is very useful to put up your performance. A couple of scenarios here. The first scenario here, you can use local SSD to hold up your Windows page file to speed up the page fault handling for Windows. And then you can also use the local SSD to hold the temp.db file. Generally speaking, it's a good idea to have a dedicated disk to host all your database. So when you format your disk, format your file system on the disk, right, we suggest you to set the allocation unit size as 32K because this will work best with the underlying PD infrastructure. On the on-prem environment, usually we heard the suggestion like, hey, keep your data disk and the data file and the log file separate on different disks for the isolated performance. But however, on cloud environment, the persistent disk is already distributed disk. It backed up by a lot of disk and the machine on the back end. So keep the data and the log in the same large PD. You will not lose any performance. And it will make your life a lot easier when you deal with things like a backup. Again, this is a very high-level summary. If you are interested, you can go to the two links here for the best practice we recommend for the Google Computer Engine. To summarize, today we go over the basic SQL Server stuff on Google Computer Engine. We had deep dive on the always-on availability group with all the technology behind the scene. We reviewed the storage and the disaster recovery option, including how to use VSS-enabled PD Snapshot. I hope you find the information here is useful. Here's some additional information you can follow if you're interested in how to run the SQL Server on Windows. I want to highlight the 3 white paper here, written by Brad Oza. This is a very detailed, comprehensive guide to how to use the SQL Server on the Google Computer Engine. Highly recommend. There's another talk on the conference. Unfortunately, some talk is conflict with this talk. If you are interested to run the Windows workload on Google Computer Engine, I recommend you go to tomorrow at the same time, the IO 220, deploy Windows-based infrastructure on the Google Computer Engine.